introduce to this audience our speaker, the engineer XAVIER FOUGER, Senior Director for Global Academic Program of the DASSAULT Systems. An industrial engineer, XAVIER FOUGER joined DASSAULT Systems in 1990. His experience and involvement in education is very broad and permeates his entire professional career. He created DASSAULT System Learning Lab that conducts collaborative education research with various universities on the use of digital technologies in education and the development of lifelong learning of emerging engineering practices. Current research field in teaching emerging engineering practices all related to learning new practices in the industry renaissance. Social innovation, precision agriculture, Internet of Things, virtual twin, active manufacturing, smart systems like farm, factories and buildings, and system engineering. He was a founding member of the International Federation of Engineering Education Societies and the Global Engineering Deans Council, steering committee member of the European Society for Engineering Education. He was awarded the 2016 Peter I Medal of the Association for Engineering Education of Russia for significant contribution to the development of engineering and engineering education. He is a fellow of the American Society for Engineering Education since 2018. XAVIER FOUGER is an expert for the French Engineering Degree Accreditation Agency, a member of the Consultative Board of the UNESCO Award Center for Problem-Based Learning, and a board member of several engineering schools. His current focus is on developing industry-inspired learning centers, establishing educational government programs, and nurturing collaboration with engineering education societies. The theme of Engineer XAVIER FOUGER lectures today will be this Engineering Education Forum, is Engineering Education for Industry Renaissance. ITA and the organization of this event thanks very much the participation of Engineer XAVIER FOUGER and DASSAULT Systems, and also PROF for making this possible. Great honor to receive this event. Thank you very much.
Good afternoon. I will not be having a phone call, but I need this device to tell me that I should stop in 40 minutes. Then I will have 5 minutes left, and then you will have questions. I'm so sorry not to speak Portuguese. It's a language I like to hear. The music is nice to me. But sorry, it will be bad English. Bad English and good IT are the two languages of the engineer of today and of tomorrow. The question of this conference about what the engineer of tomorrow will be, I think it's a very essential one. It's essential because it has a big impact on our industries, on the competitiveness of our industries. And it's also a big question because it's not easy for institutions to reform themselves, to produce this new engineering. It's not easy. But it's possible, and we see examples more and more. And my objective is to give you a few more examples from what you have heard already, and hopefully to inspire your own thinking. The purpose of the company that I'm working for is this one. It's to provide virtual environment of everything, to simulate everything, to make everything better. It's another way to say this. And when I say everything, it's that we have to push the boundaries of engineering innovation and therefore of engineering education from the industry circle to the society as a whole. And this is another difficulty in academic institutions, You can bring a machine into your institution, but you cannot bring a factory or a small one. You can, but it's difficult and expensive. You cannot bring a city inside your institutions, because the city is the context of many engineering activities. You cannot bring a planet into your labs. So the only way to do all that, to bring the context, the broader context into the educational environment, is to make it virtual. And that's why we feel we have something to do with you, because our job is in virtualizing everything. Everything that exists, everything that existed, and everything, above all, that will exist. But not what will not exist. We are not talking about video games. We are talking about computer models of things that will exist, which is totally different. But it has an advantage. It looks visually, and it's attractive to younger people because of that. So these are a few data about the company. So we see ourselves more as a scientific company than a software company. Because when you try to simulate everything, representation of this everything, what is the model of a city? What is the mathematical equivalent of a factory? And then you do programming. But first you have to think about the modeling, the abstraction of the reality we want to simulate. That's why we feel more a scientific company than just an IT. Of course, at the end we produce computer tools, but that's just the output. Well, numbers. If you have questions about the numbers or anything, we will have questions at the end. This is a little more interesting. It is showing that the industries in which these solutions are used are very diverse. Historically, it has started in aerospace. Our name is DASSAULT, but not Dassault Aviation, Dassault System. So we came from Dassault Aviation because the aeronautic industry has always been faster to innovate in new methods of engineering and of manufacturing. They always have been a step ahead. I remember when I was younger, I was working with BMW in Munich, and we were traveling to Bombardier in Canada just to show them how they were doing digital mock-up. Digital mock-up is more than just representing something in the computer. It is a process organization. And at that time, Bombardier was doing it, and BMW was still learning it. And that has other consequences. These new ways of doing things are changing very fast. They are evolving very fast. Especially currently, as we have Industry 4.0 and all the automation that comes with it. It's fast. And now I'm in charge of helping educational institutions to be as fast. That's my daily life, trying to take something that goes fast and bring it into something that goes less fast. Because we have traditions, because in education, you must think about 5 years from now, but your students of today, they will be professionals in a few years. So you have to imagine what will be the market what will be the skills necessary in 5 years. And the problem is that no one knows. No one knows. We can imagine the skills, but we cannot imagine jobs. So we have to pay attention, we have to invest time. We, the soul system, and you institutions, in thinking about what will be those jobs in 5 years. And we know we will not find the answer. And in 1 year, problem will be the same, because the 5-year horizon will be moving. Anyway, this is a challenging exercise. And it's an exercise in which we as a company have that privilege to work with all these companies here and many others. There are 250,000 companies that are using this solution. This is just a collection of famous names. We work with them to understand where are they going. How would they like to change their own processes? And all this knowledge we translate then into functions for the software, but also into educational activities with institutions like yours, so that you can accelerate the consideration of these future methods. The history it's a 40 years old history. At the beginning, we just wanted to replace the drawing board with a computer. We did a two-dimensional design. And quickly, when the first NC cutting machines appeared, we started to need 3D. With 2D paper, we could not drive an NC cutting machines. But with a computer model, we could drive an NC cutting machine in the 70s. And then over time, we went through ages that added each time more sophistication to these applications. Digital mock-up was a very big milestone in our history. We placed it when the Boeing 777 was done. Because that was the airplane that was really almost totally done first in a computer model before they made anything physical. And then we started modeling not just the complete system, the complete mechanical, electrical, hydraulical system, but also the life of this system. How will it be operated? How will it be maintained? How will it be recycled? Recycling an airplane is not the biggest challenge. You see cemeteries in the United States of dying airplanes. Recycling a nuclear power plant is more interesting. Well, from an engineering point of view, it's much more challenging. And we are now in that period where many of these plants have to be decommissioned. They are at the end of their life. But they were designed at the age, not this one, but this one, at the age of paper. So what these companies who operate power plants are now doing, they are redesigning the existing the plant in 3D, because they will need the 3D to extract the components, to plan the sequence of dismantling the plant. So this was the age of product lifecycle management. And we now, for the 6 last years, are convinced that the next step will be something about modeling not just the technical system, but also modeling the the way users of this system will use it, the experience of these users. In engineering education, the tradition is that we give students specifications. Please do that. Solve that problem. But it's rarely the case that we tell them how to create those specifications. In many institutions, the problem is known, and the students do the solution. The new thing, and everyone is convinced about the need for that. The new thing is that before producing technical specifications, we have to describe and to model the problem we want to solve. And the problem we want to solve is about modeling the experience of the user, the final user. I like the story of the Boeing 787. I'm sorry to give Boeing examples, but we are not so far from Boeing here. The 787 fully composite was the way to satisfy the traveler. The air is more humid, and when you have humid air in an airplane, you cannot have a metal body because of corrosion issues. The pressurization, the altitude is lower, the lighting is different, so that at the end, you feel better as a passenger. That's the experience. But to get there, you have to change your whole manufacturing process, your whole engineering process, from metal bodies to composite bodies. And for Boeing at that time, they had to retrain 5,000 engineers in that move of manufacturing technique. Well, at the end, they added, they still put some wires in the skin of the airplane just because of lightning to protect the airplane from lightning. But this changed nothing at the experience of the passenger. And if you had that chance, I had it once, to travel in a Boeing 787, you really feel better at the arrival than in any other airplane. Just because of these things. With this age of platform, synchronously, there is a big change happening in industry. We at Dassault Systèmes, we call it the industry renaissance. We don't call it industry 4.0, because industry 4.0 is an element of something that we believe is bigger, more profound than just automation. What? That's what this next video is explaining.
Invented by Johannes Gutenberg, triggered the revolution of the Renaissance. It made books and knowledge available to many. It changed our world, just as digital technology today. Now it is time to live our own Renaissance and invent the industry of the 21st century. The new book is the experience. It's much more than digitalization and automation. The industry renaissance combines the real and the virtual to inspire new ways of inventing, new ways of learning, producing, and doing business. New categories of industrial companies, and new categories of solutions for new categories of customers. Game changers of the industry renaissance build a culture of knowledge and know-how. A new economy organised around value networks and experience platforms. In the age of industry renaissance, it is time to empower the workforce of the future. Industry renaissance is all about humanity, experience and sustainability, about harmonising product, nature and life. DASSAULT system is the catalyst and enabler of the industry renaissance, powered by experience.
When we speak about new categories of businesses, new categories of consumers, we speak about something that is also sometimes called disruptive businesses. And this goes very far. 10 years ago, no one saw a Tesla car in the streets. Electric Tesla car. Today, in any city on the planet, you can see those cars. This company did not exist at that time, and it took Ford and GM more than a century to get there. I mean, Ford, GM, and all the others. So, speed and disruption are the key in creating new ways of being competitive. Just last week, a startup in the United States and a startup in France have worked together, and they announced they work together on a new project. So young kids, young students, a few old engineers, seasoned engineers, but many of them are young people. The name of the company is Boom Supersonic. What they want to do is to relaunch the supersonic travel. So you could say they are crazy. These are a group of kids. But today, this model, where you are a group of kids with that type of ambition, you can connect yourself with the big ones who will make it happen. There are today companies that are 2 or 3 people who do things that in the past were done by large institutions, large companies. Because of the way of working in a connected manner globally. This all requires new skills and starts to define new roles in industry. We consider we have to work on 4 dimensions. Lifelong learning, because our students will not be, like me, working all their life for one single company. They will change it. They will be mobile from one business to the next, from one employer to the next. And that means they will need specific skills of relearning. And then we have the roles and the skills of the future. These roles that we do not know yet, these skills that we start to spot. That's the difficult exercise. That's what we should be doing together. That's what this conference is about. In DASSAULT system, we have created a special group of people who are really, they do only they watch, they survey the planet to see how skills and roles will be evolving. For us, it's very important because this will determine what we have to put in our own software. We consider that, you remember from that video that it is said the book is the experience. The same effect the book, the printed book, had on knowledge dissemination. We consider the digital experience will have on learning in the coming 300 years. And the example I gave you of these startups are just little examples of something that is happening. It's that talent, knowledge, know-how starts to produce economic results in configurations where the partners, the actors, the players are dispersed in value chains that exist today that will be different tomorrow morning and change again the day after. Groups of people working together on one project, the next project comes, another group forms. They will never meet, they don't need to meet anymore. They will be working with distant people. All these four directions create this big change that we call the industry renaissance. And the tool that we provide, that is called the 3D experience, has been designed to support, to facilitate, to accelerate this transformation. This tool has already, it's called the 3D experience, it has already been adopted by many large companies. Here I just put the recent story of adoption by aerospace, a few aerospace companies. And we are talking about changes that will last 30 years. You don't change your innovation infrastructure every day. Here we are talking about the infrastructure for innovation that will be valid for the 30 next years. And this is a big challenge on educational institutions. Because all these companies, and here again, you see only the aerospace, all these companies, they are in that process where they are preparing their transition to this 3D experience. And they are looking for young engineers who can bring them that knowledge. In France, currently, if you are studying in an engineering school in which you learn this 3D experience, you are hired before you graduate. The headhunters come in the school before you graduate. Why? Because these big companies, they need this knowledge. So this creates a pressure for accelerating the educational programs that include this 3D experience at a time where something else is happening. The industry renaissance happens in the industry, and in education, the vocabulary, the meaning of words is changing. When we spoke in the past about learn anywhere or learn anytime, today we speak well, anytime. It was, okay, I can learn when I am at home, I can use my laptop and work from home. That was anytime. Today, anytime means also any age. I'm 80 years old, I learn again. So this anytime has a bigger meaning than before. Many other words have another meaning. Learning by doing is getting experiential. must happen in the most realistic context. If doing, for instance, is a student project, is not the answer to a problem that has been posed by the educator or invented by the educator. It's a problem that comes from the real world. And the real world is not just industry, because the context of learning is now the planet. It's not just the industry. You cannot imagine new systems without considering the environmental effects. The relationship between academia and industry is also evolving. It was very sequential so far. You had advisory boards, for instance. The advisory board meets at that date, gives advices, and says, goodbye, we meet again next year. And during that year, as an institution, you try to think about ways to translate these thoughts into your practice. Now, this is now a continuous work. And that's my main subject. The relationship between academia and industry is more and more co-creation. It's more and more co-delivery of education. Even in engineering education. Well, ITA was a little bit in that spirit, because you are entangled with the prayer. That was a prefiguration of something that today is getting more general. Well, and the learning is getting more social. We move away from structured groups of learners to co-learner, peer learner, that are not necessarily structured. You don't know all of them before they form the group. Groups form randomly in a place that is internet. So with people that are maybe in another country, but that have that knowledge or that have that need to learn that you have here. It's also the way more and more industries are working. The platform we provide is the 3D Experience platform. It's composed of applications, of which the best known in aerospace is CATIA. SolidWorks is well known also in education. And then you have many other tools that are all converging on one single platform. This is another big change. Industries are moving from series of applications, sometimes connected, to a new notion of platform, of innovation platform. It means an infrastructure on which everything happens. And this is a challenge. It's a challenge for institutions to do that move. Because when you have CATIA on your laptop, it's easy, you install it, you go, you work. When you have an infrastructure such as a 3D experience that connects every person in the university or partners outside the university, then it's like when you install your mailing system. It's not anymore just one single individual application. So there is some challenge, and we are fortunate enough to have good people here in Brazil to make that easy for institutions. Roles are shifting. There are many activities that will disappear because intelligent machines will do that. Including intellectual activities. We see now computers writing articles instead of journals. Well, we see, of course, machines doing things that only humans could do so far. And because of that, a phenomenon is happening. In an industrial structure, you have operators, you have technicians, you have engineers, you have a kind of hierarchy, if you want. Each of them have roles, and each of them have activities. What is happening is that machines are replacing humans in activities that are low added value or low intellectual added value. And that causes operators to be more a little bit of a technician. Take some activities that were so far technicians' activities. Similarly, technicians take activities that were so far engineers' activity. Everything is getting a little bit more intellectual, more sophisticated. And of course, what is left atop here for engineers is space for what they are now also expected to provide, which is innovation and entrepreneurship. So, wherever I visit a university on this planet, the question is how to introduce innovation and entrepreneurship into the engineering curriculum. So that is calling for a transformation of the way people learn and the way we educate people. And one first instrument that we have seen emerging over the last 3-4 years is a notion, which is the notion of centers that are inspired by companies and that are places where people will acquire new expertise about new techniques as part of their curriculum in engineering or in their training as a technician or in their training as an operator. And one of the legitimate questions for educational institutions is that threatening the role of educational institutions? I think no, because what we have seen so far is that these centers, they always emerge as a collaboration between industry and universities. A good example, the most impressive one in terms of technology, is the one that has been inspired by Airbus here in Wichita, focusing on aerospace practices, new practices for aerospace, new techniques. And I told you, aerospace is always first. It's also aerospace that is inspiring the other centers. The one in, and then we are in India, this one is inspired by the Federation of Aerospace Industries, not a single company. And this one is very Indian, because there are 45,000 students who will receive who are now receiving the 3D experience, connected to each other. A collective brain of 45,000 people. I am curious to see how it will evolve. But that's the type of size of those centers. These are just samples. Many others are appearing. And I would dream of having 1 or 2 of such centers in this little country called Brazil. I spent my life visiting such centers that are in construction. So finally, I look like an engineer, because in the press when they need the picture of an engineer, he always wears a helmet. So I am wearing the helmet very often because we visit places that are physical buildings inside the campus or outside in a new place in which these things will be done. A large building, big equipment, a new type of place for learning, but also for visiting, for young kids to see how things are done. It's like if you would be in a science museum, it's to attract them, but it's real learning that is happening there. It's also for continuing education, because these places are not just for your students, but also for professionals who need to learn the new techniques, the connected factory, the Internet of Things, the additive manufacturing, the collaborative robotics, and all these things. Centers are built around equipment and expertise. The problem is not so much the equipment. Equipment is just having some money to purchase it. Expertise, you must find it where it is. And we are talking about industry practices that are emerging. They are not yet routine. It's not like in NC 13 where things are so well proven by history that we have an abacus sticked on the machine that tells you the parameters. On a 3D printer, for instance, we don't know the parameters. We have to invent the parameters each time we do a new part. I'm not talking about plastic 3D printing, I'm talking about metal 3D printing. I mean, public funding is decreasing on universities. And this is working very well when you make it more complex by associating not just university students, but also students from vocational or from the technical colleges. It works at a distance. Here you see two examples of how this platform has been used at a distance. First example, an extreme in dispersion, in size, in distance, from Chile to China, groups of students working every year on a project, not meeting, but producing a single, consistent result as it happens in industry. Engineering between Embraer and Boeing, between San Juan dos Campos and Seattle, is a practice that will become, I think, and I suppose you think, more and more routine. The example on the right is another extreme about young people. This example comes from high schools. And when I see my colleagues standing here and my quacking signal here, I should approach the conclusion. So I don't comment this any further. Because these centers can do much more. They can operate continuing education and make revenue out of that, based on about those new industry practices. Here is an example of a university doing that. They do continuing education and they do academic education using the same educational knowledge for both. So they developed the content once and they deliver in two situations with two different modalities, but the content, the knowledge is the same. The subject in that case is collaborative robotics. How to program, if you are an industrial engineer, how to program the collaboration between a machine and the human without making the human desperate. If you give the operator the impression he's there to serve the machine, you have a problem with the operator. After a few months, he will be depressed. So you need psychologists when you program such a machine, combination, or when you train the engineers who will be doing that. There are government programs many countries that are accelerating this. I have no time to tell you that, but be aware they exist. In France, we have the chance that this government program, which is the one described in the middle, which is based on such ecosystems of skills that they accelerate. These are industries, these are educational institutions that work together on one industry subject. And this coincides with centers that are inspired by businesses. Again, many of them in aerospace, but not only. A big one is currently growing in Toulouse, and another one near Paris, inspired by Airbus and inspired by Safran. So the challenge of the educator is this one. We don't know the jobs of the future, so what should we do? What should we teach? And I think the best thing you can teach is one skill, which is the skill of solving problems, the skill and the skill of learning. It is a skill to learn. When you are in a problem-based context, you will, or CDIO is another methodology for problem-based learning. You are expected to solve a problem that is, for which you don't have the knowledge. You are obliged to look for the knowledge you need by yourself, deliberately, as a student, to find it. Of course, the educator helps in finding it, but the knowledge comes at the time of the project. The course comes at the time of the project, and not vice versa. For that, we have parameterized this 3D experience in a new manner. It's just a set of parameters. It's nothing special. You take that platform, you download a framework in which you will find tools for these 5 activities, looking for inspiration, because looking for inspiration is getting one of the activities of engineers now. It's not taking specs, specifications, it's creating the specification from the inspiration that exists probably already on the internet. How to find it in a structured manner with a precise methodology and with appropriate tools. Innovation is producing ideas. The digital, the virtual posting, the brainstorming that you do in the system with people that are 20,000 kilometers away from you, but you brainstorm at a distance. And you keep the memory of the post-it. Creation is engineering as you know it. It's producing the solution, designing the solution. And we add to this framework, to this parameterization of the 3D experience, 2 large categories of tools that are specific to your educational context and that are about learning how do students access to that knowledge they need for their project and evaluation. How do you, educator, evaluate their work? Not just the result, but also the process. Not just the group, but also the individual. This is called ELIS, this framework. It's just the name of the framework. It's not something that we sell, it's something that you download when you have the 3D experience, you download that. Some science exists about this methodology. There has been papers published in the educational sciences, of which one on your continent by the Universitat Nacional from Bogota. That was assisted by PROF. PROF went there to help them start. So I know they are working here. You are in good hands. And conclusion, that's the last one. I was happy at the beginning of this week to visit Turkey class. Because they started using the 3D experience less than a year ago. And today, their students have projects, but not projects in which they do just design of 3D. They have projects in which they take the platform as a platform, doing the project management also on the platform. Not just a new way of doing CAD, but a real way to anticipate how they will be working in industry. This I have no time to comment, don't worry. We are on the road of a changing DNA of the engineers, and we do think that the big characteristic of the changes in this general spirit of an engineering are these ones. Just take the intelligent machines. If you give the power of decision to a machine, don't you think there are profound ethical questions that have to be considered by the engineers? If engineers can put the software in a car that is lying about the emission, is that not an ethical question? It's not an ethical question to put software in an airplane that disempowers the pilot when the sensor of the angle of attack is not sharp enough. These are all ethical questions. They are not specific to an industry, and they are not specific to an engineer. All engineers need to have this ingredient in their brain. But there are other categories of changes that I think on which we could spend one conference on each. But I am not allowed by Leandro to do that because he's waiting for me to stop to allow a question. With that, thank you. Can be in Portuguese, you will translate.
Why in Airbus America's engineering you wish that ethics you mentioned as the most challenging sector we have?
Why?
You have mentioned that Airbus America's engineering wish that ethics is one of the most challenging industry to talk about the other sectors. Why?
Because as a result, it's just impressive. It's a big investment. The nature of equipment there is phenomenal. That's the reason. And they have been early. They have been among the first to do that. These are the two reasons. I don't know yet about the learning outcome because they are at that beginning, but at the stage they are impressive.
Como as escolas, as universidades, as escolas de engenharia francesas estão se movimentando para estabelecer esses novos paradigmas educacionais?
You speak of the French schools. The French schools are under first there is money. The government has opened a first wave of funding for this modernization. At the beginning of this year, it's 50 million euro, and this they want to do for 5 years in a row. That is the government. And they have these clusters, they have 100 clusters across the country, and they have created a new category which they call the cluster of excellence. In French, it's campus des métiers, des qualifications of excellence. If they fulfill additional conditions, additional to the ones they had to verify before. So these conditions are quite simple. it has to involve more higher education and research. It has to be a physical place. It has not to be a virtual cluster dispersed. It has to be in a single or two physical buildings, to make it simple. Number 3, it has to work closer with industry. They did already, but not as strong as the government is expecting now. And number 4, that could be interesting to you, they must have international collaboration. So I dream of a time where one of these centers in France, we could match make with one equivalent center here. So that's what from the government. And then you have from the industry. And the industry is funding these centers. The new buildings, the new machines. I could show you, sometimes it's gigantic. I was visiting the one you see with the helmet. I was visiting the center that Michelin is building in the middle of the country. This center has cost, the investment is 30 million euro in a brand new place. And here they will be having all sorts of machines, including metallic printing machines, the expensive ones. And they will duplicate everything they do physically, they do also digitally. It's the virtual twin. So the upper floor is for digital, and the ground floor is where they have all the machines, and then they have a big area also for the public. This is important. There is a lack of attractiveness in those jobs. Not so much in engineering, but in the technicians' jobs. That is very serious. It is preventing subcontracts. So, and why is it so? It's because the young people, that's the industry, it's dirty, they have an image of industry that is negative. And the whole industry in the country, and in other countries as well, is investing a lot in trying to change that perception of the kids, of the young generation, that industry is a difficult job, a dirty job, which it is not anymore. If you visit the factories of today, it's cleaner than in your home. I exaggerate, not in US, of course. So these are a few things that happens in France. And are you in Italy?
Yes.
So your counterpart, which is super old in Toulouse, is heavily involved in this creation of a center that is called the Occitanie Center. And also they do their own center for new practices for the industry of the future inside their campus. Just their own, in addition to what they do with the regional ecosystem, they do also their own. But it's like ITA, it's a school that is funded by the Ministry of Defense. They have plenty of money.
So my question was that, in your opinion, what is the one thing that universities can do to make their engineering education more relevant? You talked about several things. What is the one thing that you think is the most important?
Can I say two or just one? Because if it would have been two, I would have answered Choosing one is always difficult. He's torturing me. I would say it's changing the perception of what an engineer is. Not so much in the educational ecosystem, but outside. It is not normal that jobs like show business, football, finance, crime, almost the same, are more attractive to young people than the job of creating something new. And I think this generation of young people we see is ready to think this way, to make this reasoning, saying that there are good jobs, well paid, the one I mentioned. And there are also good jobs not that well paid. Engineers are not the best paid, but much more rewarding to me as a human person, because I will be creating something useful. I frankly think that this new generation, and it's international, is willing to do something with their lives that is different from the motivations of our generation. So the challenge for engineering education is to export this perception of what engineering is going to be or is about to be. It's not just for engineering education, industry has to do its job also. And make that visible in the eyes of this new generation. But immediately after this first top reason, there are 70 others within 1% of importance.
One question that my mind that to move to this renaissance, I think that you have young people that have a lot of creativity and also that the guys that have a lot of experience. How to join this business, or is that a movement is to join this experience with this creativity, and how to do this?
Yes. There is an example that I love. It's I don't know if you could watch the beginning of SpaceX, the company. At the beginning, Elon Musk had collected only young people and creative, energetic, breaking the barriers, etc. Even very social, interactive. And he rapidly understood that it's not the right mix. And he started hiring retirees from NASA, from other agencies, to create the mix, the intergenerational mix. And I think there is some magic in that combination between the young and old generations. Well, old I call myself, but you. But I have no final answer how to make this happen. I know it is difficult, especially in educational institutions, because we have professors who have done an extraordinary job for many years, and now we would come to them and start telling them that's not the way to do. There is a human transformation, a human management of this transformation that has to be done very carefully. And then the challenge is on the leadership of these institutions. How to make that in a way that takes the benefit of the previous generation and the new one at the same time. So, but what is sure is the better you do that, the faster you will be doing it. So it's not a question of waiting for the end of a generation. You can start with this generation that is here for 30 years. If you wait for them to be replaced by young professors, you will wait an eternity, and you will lose the opportunity to create more competitiveness.
Just a comment. It seems that the young people, they don't want to have formal courses. And the experience that we are reporting, that the motivation is to undertake projects that span countries, culture, and a lot of things. So, but the way we organize our courses, or we give our courses, is very formal, it's very restrictive, has to spend a lot of time in classes. So it seems that you are providing some way of giving courses, but on the other hand, I think the challenge that the industry, that the young people want, the innovators, the entrepreneurs want, is something more fast. It doesn't have to have that kind of stairs of degrees. It can involve many people with different experiences, different, I would say, many areas. Just a comment.
Yeah, I think it resonates with this same question. The reform of the curriculum is something in which, like in any human change, you will have legitimate and non-legitimate objections. I give you one very frequent non-legitimate objection, and this is when people tell me the curriculum is packed. We cannot add anything, and I agree. The time a student can spend is limited. You can extend it artificially by having them work out of school, in clubs, in projects. Yes, but it is limited. And then we come and tell you, you should put more ethics in your curriculum. So that's not about opening a course on ethics. It's about training professors in spotting the ethical dimension in the projects they are doing with the students. So it's not more time, it's at the same time as you do other things. It's overlay additions. Most of the soft skills that industry requires from your students, you do not teach them. It's not something you teach like I am teaching now. It is something they have to experience. And the format for you to have them experience it is the project. And in the project, the soft skills will be developing at the same time as the technical skills. And then there is one objection that is very valid from educators. This to happen, project-based education to be problem-based education to be more general, is a management decision. it is a system change. It is not an individual matter. For instance, we all know, good problem-based learning is more expensive for an institution. Because if you are a supervising educator, you can supervise groups of students, but unfortunately, there are 20 to be supervised. And you can supervise them only a few hours in a week. And unfortunately, they need coaching at any time. So you cannot be with them with all your 5 or 10 or 20 groups all the time. This, I violently agree with, because this is what this platform is helping to solve. Because the mentoring of your team will be done on your anytime. That means you are with your smartphone or any intelligent telephone, and you receive alerts from the 3D experience platform that are telling you the group number 12 has published nothing since 48 hours. So, and this is giving you the indication, oh, maybe I should intervene. Maybe I should contact her, which can be on the phone. I don't need to be physically with them. Or it tells you, oh, in this group of 5, I see publishing of content, of results, of text, only by these 2. The 3 others do nothing. Should I wait? So that's okay, it will help you for ranking the individual at the end, because you see who has been working. But you could also decide that, because you have this signal early enough, decide to intervene and ask what is happening. Why are these 3 doing nothing? And maybe they have good reasons. You never know. So project-based education, problem-based education is expensive, but it is also one of the human activities that can be assisted by technologies such as the 3D experience platform. Does that bring a little bit of information?
Last questions. So, Monsieur Fouger, could you, about the skills of the future, could you resume or say just one skill that is would be the most important that we will achieve?
It's like when you ask a chair with four legs, what is the most important?
Or resume, or say just one word that could say everything.
No, but let me think a second. If you ask me a challenging question, give me a second to think. I think if I say what I want to say, I start a new debate. The skill of learning. So it was a short answer. I must be happy.
Thank you. So we say thank you to Mr. Fouger.
Just to complement our professors, Ethan has the 3D experience. He's under Professor Haddadi tutorship, now training with professors with this tool, which seems to be a very good step for